welcome to the STEM in 30 Mission Debrief.
For those of you who don't know, STEM in 30 is a show produced here at the National Air and Space Museum for middle school students.
Today's show is all about Apollo, and we brought in a couple amazing guests. We've got Margot Shetterly, the author of Hidden Figures.
And we have Christine Darden, who is a mathematician who was featured in the book. Welcome to you both. Thank you so much for being here today.
Thank you.
Christine, let's start with you. Tell us a little bit about the work that you did with NASA.
Okay, well, I was hired at NASA in 1967, so it was 2 years before we walked on the moon. And I was hired into the reentry physics branch, which and the engineers in that branch had done the calculations for how the space vehicle would come back into the atmosphere to make sure that it didn't burn up or get too hot or bounce back out into space. And so they had done the calculations for Apollo before I got there, but all of the wind tunnels were in that area. They were the hypersonic wind tunnels that had speeds up at Mach 8, Mach 10, Mach 12, and things like that. That's times the speed of sound. And so I did most of my work doing calculations of how they were running tests, making sure that they were getting good data from the wind tunnels and things like that.
Margot, tell us, how did the book Hidden Figures come about?
I grew up in Hampton, Virginia, and I was really fortunate to know Christine and many of the other people because my father worked at NASA as a research scientist. So I got a first-hand look at this very exciting world of NASA at the time. But it really wasn't until 2010, when I started doing the research for the book, that I started really delving into what these women were doing, why they had, or how and why they'd gotten to NASA, and how their careers intersected with the history of NASA, the history of spaceflight, the history of aeronautics, and the history of our country. So I learned so much about the people and the places that I had grown up with doing this research.
We got a question in via email, and the question is, how would the calculations done by the Hidden Figures human computers team be done during a similar mission today?
Well, I believe, they would use the calculations on the computers that we have. They're governing equations and everything. And so computers were just coming in when I was hired there, but certainly computers have improved tremendously over the years. And so a lot of the high-powered calculations would be being done by the computers, the electronic computers.
What did a computer look like back then?
Well, the first one I saw was an IBM, and I forget the name, but it was, not so big and everything. And when I first used the computer, I had to sign up for it so I could get to it at night and run my code on it. We had to punch cards. Every line of the computer code, we would punch a card with the instruction on it, and then you would have a deck of cards to read into the computer. And then it would follow the program through those decks of cards. And sometimes if we would drop those decks of cards, we would have a time trying to get them back in the right order because it had to be in the right order. And so if we had a big box, we would draw a diagonal curve across the top of the card so we could at least get them almost in the right order.
And now I have a computer sitting on my lap.
Exactly, yes.
Margot, we have a question from Mira who wants to know how much of the movie was true and how much of it was dramatized.
That's a good question, and everyone really wants to know that. And there were a number of things that were dramatized. For example, Dorothy Vaughan never learned how to drive, and she's the one who's portrayed as the driver in the movie, just as an example. The thing that was very interesting for me, having done all of the research and looked at all the documents and talked to the people who lived the history, was what was necessary to take all of that, which is all this nonfiction information that I put in my book, and make it into a movie. So while the film took liberties with the facts, and if you've read the book and you've seen the movie, you can kind of go back and forth and see what was true and what wasn't true. The thing that I really appreciated was that the truth of the movie, of the women, of their character, of their circumstances, and of the times, I thought they did a very good job in portraying that. But yeah, it was a very interesting educational experience to see what it takes to turn a true story into a movie story.
Was it pretty cool to see what you had started on the big screen?
It was pretty cool. It was very cool.
All right, we've got a question from Lois on Facebook. What type of math do you need to know to work at NASA?
Wow, it varies all over the place. You need to know how to add and subtract and do fractions. You have to know all of that, because as you get into the higher math, you're still adding and subtracting and doing fractions. And
so now wait a minute. You're saying that the middle school math that these kids are learning today actually is that building block towards working at NASA?
Absolutely. I said I was going to tell a story. I tutored a young lady in geometry when I retired. And I started asking her some geometry questions, and she said, she talked and she understood everything I was talking about. And I said, well, wonder why she's not been able to work the problems. I gave her some problems to work, and what she was missing was fractions. Mm-hmm. She had missed fractions in the 3rd or 4th grade, and you've got to know, when you do calculus, you got to know fractions. So learn it then. It's better to learn it in the 3rd or 4th grade than it is to wait.
Well, we have another Facebook question from Rudolph, who wants to know, well, first off, I think he wants to know how accurate were the slide rules used back in the Apollo missions, but maybe we ought to first define what a slide rule is and then talk about their accuracy.
Wow. Well, I never used one very much, but the slide rules had scales on, like a ruler almost, and you could move parts of it, and you could do multiplication and square roots and things like that, depending on the scales of the part that were movable on there. And they had to be built very accurately, and they were pretty accurate in doing the calculations. And we were also very glad when the handheld calculators came out.
I will say one of the parts of my research involved finding a slide rule on eBay so that I would actually know what it looked like.
Were you able to learn to use it pretty easy?
A little bit, but it's not easy. You really, it's not as easy as putting a number into a calculator or a computer, for sure.
All right, we've got another one from Abby on Twitter, and she wants to know, was there one thing that really inspired you to write the book?
It really was a series of conversations between my husband and my father, who were talking about the women who had worked in the early days of NASA and of the National Advisory Committee for Aeronautics. But it really became kind of a quest. I knew the end of the story. I knew the women. I knew about NASA. And it became this curiosity of, well, I have no idea why they were there. And I got very curious about airplanes and was very interested in the origin of airplanes, and that had happened in Hampton, Virginia, where I grew up. So it really became this all-consuming quest to see the beginning of the story and to really understand the origins of this great American story.
We have another question from Andrea from Facebook. What message would you give to women who are dreaming of working for NASA today?
The message I would give is, don't let anybody tell you you can't work for NASA, but at the same time you need to realize, if you like math, you like physics or science or engineering, that you've got to take those classes, you've got to learn how to do the work and everything. There are no excuses, but you can do the work. And that was how I felt as a child. I said, if it's 1,000 pounds I have to lift to do the job, I'll accept it. But don't tell me I can't do it just because I'm a female. But the females have to hold their own weight when they're doing the work at NASA. And but you can absolutely do it. And I am so glad to see so many women going into so many areas now. And I had a wonderful career at NASA.
All right, so we've got another Twitter question that kind of follows up on this. When will we see the first woman on the moon?
Well, maybe in 2024. How about that? I think, I mean, you know, we've certainly got female astronauts all over now, so there's no reason why they could not be part of that group.
Great.
Christine, we have another question for you from Facebook. Vishal wants to know, when did you decide to choose mathematics as a career, and did you have a teacher that influenced that?
I took geometry in the 11th grade in high school. Didn't have a lot of math in high school. So in the 11th grade, I took plain geometry, and I absolutely fell in love with it. And I decided then I was going to major in mathematics. And on the teacher reverse day or whatever, I put on my sack dress and my T-strap shoes, just like that math teacher, and I taught math. But I really loved it. And I went off to major in math in college, and that was the highest math I had in high school. And so everybody else coming in that was majoring in math, it had calculus and analytical geometry and trigonometry. And I'm saying, well, gosh, I'll just have to start where I am and learn it all. I wasn't thinking about quitting, but I knew I had to learn it.
Margot, how did learning about the paths of the women featured in the book, did that influence your path at all?
You know, it really did. I mean, honestly, I've done a lot of different things in my career, and what happened is my path fused with the women in the book. I mean, I became a professional writer when I started writing about these women. And so, you know, now I'm working on another book, and I've got another one kind of hatched in the back of my head for after that. So in this very real way, my career has connected to their careers and to their story and their history.
What can a student learn by learning about these careers and these paths?
Well, you can certainly learn a lot about math and science. You can learn a lot about engineering. But one of the things that I have really enjoyed learning from Dr. Darden and these other women is how not to take no for an answer. She was just saying, you know, if you are interested in this and you have a passion for math and science, then you know, don't let anyone tell you no. Just keep plugging forward. And again and again, when I would do the research and talk to these women and interview them, the women who moved forward and the women who really moved up in the ranks simply refused to take no for an answer. And I think that's a good lesson for all of us who have a dream, so that we are not deterred by that along the way.
And Christine, you actually had to stand up to a boss at one point, didn't you?
Well, I did. I had a master's in applied math by the time I went to NASA, because I kept taking math. When I got in college, I just took all the math I could. And I was working equations that the engineers brought in and writing computer programs to solve them and things. And I said, well, these equations are very much like the equations I worked in graduate school. Wonder why the engineers are doing these and we are not. And I says, well, it's because they're engineers. I didn't know what an engineer did, because at my hometown they drove trains. And then somebody says, well, all of the men working in engineering don't have engineering degrees. Some of them have math degrees. I said, is that right? So I immediately got on my horse to say, well, I'd want to work over there in the engineering area. And my first supervisor said, no, I don't think that's possible. And so about 3 or 4 weeks later, I said, I'm going to a higher level boss. And I went to him and I said, I'd like to know why a male and a female coming here with the same background are assigned to such different jobs. The females were assigned to the computer unit, and the engineers would kind of determine what they did. They didn't give talks, they didn't write papers, they had a hard time getting their names on papers, and they didn't get many promotions. The men did research, they gave talks, they wrote papers, and they published, and they got promoted. And he looked at me when I finished that question and said, you know, nobody's ever asked that question before. And I says, well, I'm asking it now. And we said a few other words, and then I went back to my office, and 2 weeks later I got promoted and I got transferred.
Great lesson.
Margot, we've been talking a lot about Apollo 50th. Why do you think this story is so important now? Why was it so important to talk about this story at this point in time?
I think there are a couple of reasons. One is that there's still many of the same issues that we're talking about the promotion of women, about the inclusion and the diversity in the STEM workforce. I think that's one of the reasons why. And I also think that this is also a story about imagination and about people coming together to do something that previously had not been possible. And that I think is very inspirational. We were just over at NASA headquarters and listening to the plans of going back to the moon and and beyond. I think people find that very inspirational, and to know that dream historically has included all of these groups of people that maybe we didn't know were participating. I think what that means is that anyone in this room, any one of us, could be the people, on that team taking that next step into the future with space travel. So, I think there are both current issues that are still very relevant, and I think there are a lot of issues that are very evergreen that make this a great story.
One of my favorite parts of the book, Margot talks about data that's coming in, and she calls it goo gobs of data coming in. Christine, can you talk about how much data there was coming in and kind of what that looked like?
Well, I guess I never saw a lot of the data coming in from Apollo anyway. But sure, they collect data real time as much as they can, because it takes a long time to analyze it and to learn from it. This is the bread that we learn from. Why does it do this, or exactly what the data is, and is it doing what we predicted it was going to do? Our theory is working correctly and everything. And I think one reason it's important to talk about Apollo now, a lot of people were disappointed that we walked on the moon and we had several other landings on the moon, and then it kind of stopped. And a lot of people in this country were kind of disappointed that they didn't hear a lot about it after that. But maybe the excitement is going to grow again.
Now, 50 years ago was a very tumultuous time. We were doing some wonderful things, but it wasn't all pleasant. And I have to ask you, Christine, did you participate in sit-ins?
I did. I was a student at Hampton University in 1960, I think, when the sit-ins started. So I participated in the sit-ins in the drugstores there in Hampton. And there were many of my classmates who went to Newport News, which is another city sitting right beside us. And so, yes, we did participate in the sit-ins.
And that must have given you some courage then to march on into NASA.
I think I started deciding, I'm going to have to, other people can't live my life. I'm going to have to live my own life and make my decisions and things like that. So I've got to learn to speak up. And my mother even told me I needed to talk more. She gave me a conversation course. She says, you need to learn how to talk to people and maybe ask the questions, because we do need to ask questions because people don't always know what we like or what we want to do. So we have to tell them. And I think it's very important that we don't sit back and wait for everything to happen, that we actually initiate some of the conversations.
And how important was communication at NASA at that time and in the work that you did?
Well, I would never have gotten transferred if I hadn't communicated. so that was very, very important. So people don't know what you're thinking or how upset you are. When I talk to students, I actually talk about, I have a P to the fourth power, which I said, perceive of yourself in a job that's like your goal or your dream or what you want to do. Mine was being a mathematician. Plan, what is it I have to do to get to be a mathematician? Since I didn't take a lot in high school, what I had to do was take a lot of math. And so I had to start doing that. Then start doing that math, and then persisting. Don't let anybody tell you can't do it. When I was taking some of this math, I had people riding with me and they all quit. And I had to decide I'm going to keep going by myself, work all day teaching school, drive 80 miles sit in a class for 3 hours and then come back home at 10:30 at night with my head hanging out the window so I wouldn't fall asleep. But I wanted to stick with that math, and I wanted to get it done. And it is because I stuck with that math that I actually got a job at that university where I was going, doing research in aerosol physics. And so you never know what's going to happen, but you have to sometimes get out there and keep up with things and not quit, and not let other people make you quit because they quit. And those are some lessons I learned, and I think in speaking up is lessons learning. And Dorothy Vaughan had a great story in the movie where she went to the library and got a book on programming and taught herself to program and taught everybody in her office how to program. She says, I'm not going to work on that computer unless everybody goes with me. So I thought that was a great mark of a supervisor.
Now, this question's for both of you, and it comes in from Stephen on Twitter. Isn't it true that just about any area of study, psychology, history, medicine, can be a pathway to a career in space? Have you seen that in your research?
I have. I mean, I've met people along the way who started out doing one thing and ended up doing something totally different. You know, and I think, like Christine was saying, when you love something, you persist in it. You learn what it takes to be successful in that, and really throw yourself fully into that field. But I've met people who've come from all different backgrounds who've formed themselves into engineers or astronauts along the way. I think a lot of people do come, you know, obviously, and study those fields, but I have met people who came from different fields.
Yeah, and you know, psychology apparently is a big area now where you understand people better and might be able to predict what they would do in a certain situation. So I think in that arena, psychology can play a big role about what people will do in certain situations.
Can you all tell us a little bit about Katherine Johnson?
Well, Katherine, she's a great person, a very outgoing person. She can work a room like I don't know what, but she's very smart. Katherine and I have been in the same church for 70 years. And Katherine's daughter was my classmate, and so she's a very good friend of mine. And so Katherine is, like I said, a very pleasant person, very outgoing, and she just makes friends with everybody. And we're in a sorority, the same sorority. She could go in this room and find out there were 3 AKAs in this room. I don't know how she did it so fast, but she would be able to do it just that fast. She would find it out. But a great person and very well liked.
Yeah, and I think that's one of the brilliances of her. I mean, obviously she's a brilliant mathematician, but she has just incredible charisma and a way with people, and to really draw out the best in other people and to see the talent in other people and to work together with other people. So I think that those people skills is really one of her gifts.
We have a question actually from a teacher, Lois. She teaches middle school and high school, and Christine, she would like to know what is the easiest way for her to explain the connection between sonic booms and space flights to her students.
Okay, the sonic boom is actually caused because you're flying in air. So you don't have sonic booms when you're in space. So I was explaining a little earlier that when I explained the sonic boom to students, I said, well, okay, you all have a pressure on your ear right now. If I were to blow up a balloon in this room, I am putting more molecules of air into the balloon's going up. The pressure inside the balloon is higher than the pressure in this room. When I pop that balloon, that higher pressure goes out at the speed of sound in all directions. And when that shock hits your ear, the pressure on your ear jumps from what it was first to close to what it was in the balloon. And that instantaneous change in pressure is the pop you hear. Flying in space, you're in a different medium. You don't have the air to transmit the waves, sound waves, and things like that. You've got the sound waves in this room. And by the way, the speed of sound is about 700 and some miles an hour, so it's coming pretty fast. That's how fast my voice is coming to you right now. And so in space, you have a different different propulsion method and everything, but you don't have the air. An airplane generally has, you have four forces. You have the lift on the airplane, and that's generally caused by the wing. You've got the gravity that's pulling it down. You've got the engines on the back that are burning and pushing the airplane forward, and you got the drag on in the airplane. So those four forces are particularly the four forces. Drag is when you're a kid and you stick your hand out the window, and the air pushes your hand back. That's the drag that you're facing. So the airplane basically has those four forces on it to make it move through the air and everything. In space, it's more, they go very fast up there. Those ships are flying around the Earth at 17,000 miles an hour. Very fast.
Well, if you would like a side gig, we've got a couple of galleries here. You can come in and teach this every single day. And is some of the code that you wrote still being used?
But we would kind of start out with that code that I wrote, and then computational fluid dynamics was developed while we were kind of working on that. And so we could take the designs we made from the linearized theories, which was when we didn't have the big time computers and equations and everything that we could solve. And we could actually put them in our big codes that we have now in our big computers and correct some of the designs a little bit. So we used computational fluids to actually maybe make some tiny corrections to our designs and things. And they're using some of the philosophy. The philosophy is that when you have lots of shocks coming off the airplanes in different directions and everything, if those shocks coalesce with each other, the shock gets bigger. And as far as the sonic boom goes, as that shock gets bigger, the noise gets louder. The bigger the change in pressure, the louder the sonic boom is. It could break your windows, it could crack your sheetrock. And that's why we have a law in this country right now that says there can be no commercial supersonic flight in this country. And that law was put on the books in 1971, just about the time I started working.
Christine, Margot, thank you both so much for joining us today. We really appreciate it. Let's give them a big round of applause.
Thank you.
We hope that everybody tunes in to the next STEM in 30. We appreciate you all coming in and watching today. Thanks for watching.
Thanks for watching.
Thank you.